Newton's first law, also known as the law of inertia, states that an object in motion will stay in motion unless acted on by an outside force, and an object at rest will stay at rest unless acted on by an outside force. We will first demonstrate the part of this law that states an object at rest will stay at rest unless acted on by an outside force.
I'm Sam. I'm Isaiah. And this is physics.
As you can see, the snow lump stayed at rest until acted on by an outside force, that force being my car.
The second part of this law states that an object in motion stays in motion unless acted on by an outside force. We will demonstrate this by throwing a snowball.
Straight upwards,
Straight upwards.
as close as humanly possible.
If... That's Eric. If there was no force acting on it, it would continue going upward into
Space.
forever. But gravity will push it back down.
Newton's second law is slightly more confusing than the first one. This law deals with momentum, which is mass times velocity. The modern version of the law says, the force exerted on a body equals the resulting change in its momentum divided by the time elapsed in the process. But ultimately it boils down to F equals ma. Force equals mass times acceleration. Watch as Isaiah throws this giant snowball. He missed. Now watch as Isaiah grabs a smaller snowball to throw at Eric. Watch closely as the snowball smashes in Eric's face. His fort was no match for the laws of physics.
First off, as you saw, I gathered a snowball of great mass, and it was big, and it would not reach great height when thrown, even with much force applied to it.
Then he created a smaller snowball with a smaller mass, and when he threw it, it hit Eric right in the face.
Because of its lower mass, it was able to reach greater acceleration because the equation to calculate force is force equals mass times acceleration. With lower mass, you can reach greater acceleration with more ease.
Newton's third law states that every action has an equal and opposite reaction. We will demonstrate this by throwing a snowball at Eric. And by this law, there will be an equal and opposite reaction back at me.
On a more serious note than our last example, think of a spring. When you pull on the spring, you can feel the spring pulling back against you. This is Newton's third law at work. Or think of pressing your hands on a balloon. You are pushing, exerting force on the balloon, but the balloon does not pop because the balloon is also exerting a force back on your hand, equaling out the forces, causing it to not pop.
Right, so for the third law of physics, the equation would simply be F equals negative F, for when you push on a wall, for example. It exerts an equal force back at you. While you don't move, the force pushed back cancels it in a way, because the wall doesn't move either. But what about a wrecking ball or baseball through a window? Well, those objects have accumulated inertia and overcome the force applied back on them and break through. But the force does still apply, because those objects slow down after they punch through. And finally, without the ground applying a force back into our feet, we'd probably sink right in and down to the core of the earth.
And so I cry sometimes when I'm lying in bed just to get it all out what's in my head. And I little peculiar. And so I wake in the morning and I step outside and I take a deep breath.